Hello everyone. Today I'm going to explain to you the first four problems of the code Chef Starters 49 Division 2 problems. So I'm going to explain to you the first four problems of this contest. So the first problem is valid minimum. So in this we have been given a question as so there were initially three integers or three numbers A, B and C, and after that they have only given us these three values, so minimum of a comma b, minimum of b comma c, and minimum of c comma a. So they have given us these three triplets, and we have to answer yes or no whether that these three triplets are valid or not. So if we look at the pairs a b c and ca, right? So minimum of a comma b, minimum of b comma c, and minimum of c comma a. Right. So let's first say that A is, firstly, we are saying that A is less than B. That means that this value is going to be A, right? And now let's say that A is, sorry, B is again less than C. So if B is less than C, that means that the second value is going to be B, right? So if A is less than B and B is less than C, that means that we can say that A should definitely be less than C. Why is that? Because if we like make a conclusion, it is going to become something like this: A is less than B and B is less than C, right? This could be one case. Another case could be equals to sign as well. So we can add here equals to sign as well. So this is the inequality that we are going to form, and here if A is less than or equals to C, this is going to become A. So this is like the first value, and here we have two conditions. In this first value, we have two conditions. So the conditions would be that these two values should be equal. So the first and the last value should be equal, and the second value. So this is basically B, and you can see that B should be greater than or equals to A. So this is like the two conditions. So this and this value should be equal, and this value should be greater than or equals to A. So this is the first condition. Now let's look at the second case. In this again, let's say that A is less than equals to B, but here B is greater than equals to C. Okay, so that means that we are forming something like this: A is less than or equals to sorry, A is less than or equals to B, and B is greater than or equals to C, right? So we cannot say anything about A and C here, like whether A and C they are equal or not. So let's say that A is equal for now. Let's say that A is equal. So here we are going to have A, here we are going to have C, and here we are going to have A. So that means that A is basically lesser than or equals to C. So we can say that this equality looks something like this: A lesser than equals to C and C lesser than equals to B, right? So A is smaller, then we have C, and then we have B at the end. So B is the largest one, right? So in this again, if we look, we have like two cases: this and this value should be equal, and this value should be greater than the first value. So like kind of both of these cases are same, right? So now let's look at another case where we would have something like this. Like here, let's say we are getting C, right? So here we are getting C. That means that C is lesser than A. C is lesser than A. So we have something like this: C is lesser than equals to A is lesser than equals to B, right? C is lesser than, so this means that this value should be greater than C. So A value should be greater than or equals to C. So this is like the second condition. And these two values should be equal. And the last condition we are going to look at is of, so in this we are having the first and last value. In this we are having the second and third value. Now let's look a case where the first and second values are equal. So in that, what is going to happen is B should be less than or equals to A, and here B should be less than or equals to C. So this is going to become B, this is going to become a B, and here whatever the value is coming, that value should be, so let's say that value is X, right? So that value should be greater than equals to b, right? So using these three conditions, so this is the last value. So using these three conditions, we can like print yes or print no. So this is just printing. This is just a printing statement, and then I'm returning. So this is it for the first question. Now let's look at the second question, which is high frequency. So let's look at the second question. High frequency. So in this question, we have been given something like that. Let's say f of a denote maximum frequency of any possible element. Okay, f of a denotes the maximum frequency of any possible element. So let's say here in this case, the maximum frequency is going to be 3. So 2 is occurring 3 times. So maximum frequency is going to be 3, right? And in the second case, maximum frequency is going to be 2 because here 2 is occurring 2 times and 3 is occurring 2 times. So what we can do is we can perform a operation at most one time. So like one time at a maximum of one time we can perform an operation. We can choose a subsequence like any subsequence, and we can replace every element of that subsequence to some other element. So we can do this. So now what we can do? What we can do is so like they have given us some examples. So let's first look at them. Let's look at this example. Okay, so in this example, what they have done is they have taken subsequence of alternate elements and they have changed them to twos. Right. Similarly, we could have taken directly these three elements and we could have changed them to twos. So that will leave us with our answer of three. Okay, leave us with our answer of three. So what basically we have to do is we have been given some frequencies. Okay, so let's say we have been given an array of frequencies x1, x2, x3, x4. So this is I'm talking about frequencies. All right, the number of occurrences. So let's just first look at the solution a little bit. So what I have done here is in the solution, firstly I've made a map, a nodded map, and in this unordered map I've stored all the key value pairs, right, or all the frequencies. In this map I've stored all the frequencies, and then I've made another vector B, and in the vector B I'm pushing down the frequencies. All right, because we don't care about the values, but we care about the frequencies. That's why I'm pushing the frequencies in the second array. So this is what I've done in the second array. In the B array, I'm pushing the frequencies. So let's say all of these frequencies look something like this: F1, F2, F3, F4, and F5. So these are what like frequencies they look like. And what we want is we want to like we have an array, right? And we want to take a subsequence and we want to change its value, and we want to change its value such that the f of a the operation f of a gives us the minimum possible value. Wait 1 second. Yeah, so f of a, so we have been given here, yeah, determine the minimum possible value of f of a. So we want to do this. So the optimal answer would be to do that is that let's just decrease the frequency of the largest element. So let's sort this frequency array and let's say that this is like in the sorted form only, and decrease the frequency of the first or the maximum element. Okay, so we are going to do that. So we have done this only. So why is this possible? Because let's say we have decreased this frequency. So um, so like there's like no possible kind of an answer. So we can take an example, right? So let's say we have value 5, 3, 2, 1, right? And this 5 has so let's say this 5 is a, so a has occurred 5 times, and this 3 is b, so b have occurred 3 times, right? So our optimal answer would be to select this a either 2 times or either 3 times, right? We can select this a either 2 times or either 3 times, right? We can do this, and that is going to be our answer, maximum possible answer. Okay, so this is what I have done is, so I have like reduced it. So I can either reduce this 5 to 2 or I can either reduce this 5 to 3. Let's take another case where I have here 4. I can reduce this 4 to 2 to a single value 2. Now our answer could be either 2 or 3. So this is what our answer could be, either 2 or 3, and in the previous case our answer would have been either 2 or 3 or this 3. Right? So this is what our answers could have been. So what I have done here is I have like sorted our B array in a reverse order, and then if the size is 1, so let's say I have only one possible frequency, then I'm going to reduce that frequency, and that is our answer. So let's say if the size is 1, then the answer is going to be divided by 2, directly divided by 2 plus 1 divided by 2. So let's say the value is odd, then I'm adding one value and dividing it by 2. All right. Another thing could be, let's say we have more than one value present in our array. So in that, what I'm doing is maximum of this value, maximum of like reducing this value and the second value. So the F2 value. So this is it for the second. So for the second question, high frequency. Let's talk about the third question. Now split the string. So we have been given a problem, split the string. So basically what we have been given is, we have been given a binary string. Here we have been given a binary string, and what we have to do is, they have given us the badness of a string. All right, badness of string or badness of a substring. So badness of string is basically, let's say in binary string we have zeros, total number of zeros and total number of ones. So badness of string is going to be total number of zeros minus total number of ones, and the absolute value of this. So ABS value of zeros minus ones. So this is the badness of a string. Now another thing they have mentioned is that we can like take we can make k substrings. Okay, or in other words, we would like to make k disjoint subsequences, right? K disjoint subsequences, and some of them might be empty. So we have our binary input, and we can take k disjoint. So here, let's say we have been given k as 5. So they have made here 5 disjoint subsequences. So one is 10 10 0 10, and one string is basically empty. So we can do this, and like there are different ways of making this. And what we want is, we want to make it such that so let me read the question first. Would like to maximize the badness among this k. Wait, sorry, such that the maximum badness, right? So what happens is, such that the maximum badness present in this individual substrings, that should be minimized. So that should be minimized. So minimum possible thing is 0. So here we have badness equals to 0. Here we have badness equals to 1. Here we have badness equals to 0. Right. So we want that badness to be minimized. Right. And we can take any possible substring or basically subsequence. Sorry, not substring, subsequence. We can take any possible subsequence. All right. So the possible answer could be, we can say that, let's say our badness is equals to x. Our badness is equals to x, and we can make a total of k pairs. Right. We have to make a total of k substrings or subsequences. Right. So we can make a total of k subsequences, and the badness is x. So let's say badness is equals to x, and we can make a total of subsequences k, right? Subsequences k. So what we can do is, we can like, let's say we have 1 2 3 4 5 up till k subsequences. We can let's say initially we have taken this subsequences such that individually all of them has zero badness, right? All of them has zero badness. Now we are going to have a lot of common numbers, let's say ones or either zeros. So these are causing the badness of our string. So we have like a lot of ones or either a lot of zeros. So they are causing the badness of our total substring. So what we can do is, we can split this into this k subsequences. This k subsequences. So we are going to do that only. We are going to split them in this case subsequences, and some of might some let's say there are total of five subsequences, right? There are total of five subsequences, and the overall badness was three. So one, two, three, four, five. So these are total of five subsequences. We have made the subsequences such that initially they have zero zero badness. Then we distribute this three total badness into these individual subsequences. So this is going to become one, this is going to become one, this is going to become one, and these two are going to be zeros only. Right? So that means that this is the maximum possible answer, one, and that is one. So that is so this is nothing but 5 divided by 3, right? Sorry, yeah, 5 divided by 3. So, or in other words, we can say that seal of absolute of, so this is kind of the badness, absolute value 0 minus 1 divided by k. So this is our answer. What I've done is I've done nothing. I've said that the answer will be, wait 1 second. Badness divided by the total number of pairs, right? Badness divided by total number of pairs. So here we have badness of 3 and total number of pairs as k. So let's say k was 5, right? So this value is going to be something like 0 point some value, right? 0 point some value, and we are going to seal this value up. So what happens in seal is this is going to round the value of to the nearest integer, not the nearest to the like topmost integer. So let's say we have 0 0.1, this is going to become 1, right? So we have done this only, and like this is our answer for the split the string. So we have like taken all of the count of zeros and ones, and here what I'm doing is I'm like doing absolute 0 minus 1 divided by k and sealing of this value, and we are just printing out this value. So this is like a very small solution, like just we have to make some observations. Let's look at the last question, which is monks. So let's look at this. So this is kind of long question, so let me explain you this question. So in this question, we have been given that there are initially some people, so let's say n people in a town. Okay, and what happens is some of the people decided to, so let's say any of them decided to become a monk. So what that person can do is that person can basically, initially all of the people in the town, so all of the n people in the town, we are going to have some monies or some coins. So we have been given these coins. So let's say first person has 1 coin and the last person has 5 coin. And a person who decides to become a monk, it is going to leave the town. So let's say the last person decides to become a monk, so he's going to leave the town, and the first three persons are going to be in the town. Now, what that last person who is leaving the town can do is he can give his coins to all of these people. So the people who are left in the town. So monk does not require coins. That's why he can distribute his coins among these peoples. So we have to find that can so let's say this monk can distribute a total number of 5 times for 5 coins. So let's say he have distributed 4 coins to the first person and 1 coin to the second person. So in that way, all of these persons are going to have 4 coins each. So we want to find out that how many like persons should become monk such that the persons who are left have equal number of coins. So let's look at an example. So let's look at this example. There's a last example. Here we have one person is having 2 coin, one person is having 2 coin, and three persons are having 1 coins. So let's say this person decides to leave the town. So he can distribute his 2 coins to two persons. So this is going to become two, and this is going to become two. Now we can see that total number of coins are not equal. Like coins are not equally distributed between these peoples. So this can become equal when another person decides to leave the town. It could be either this person or any of these person, right? So let's say if this person decides to leave the town, right? If this person decides to leave the town, he can distribute his 2 coins to this person. So let's say he distributes only a single coin, and he has taken the one coin with him, so he can do this as well. So this is going to become 2 2 2, and total number of persons who have left the town are 2. So we have gotten here 2. All right, and similarly here as well. So here we have 5 1 4. So let's say any of these person if decides to leave the town, like other are going to become equal. So we have 5 1 and 4. So let's say 5 decides to leave the town. So 5 can distribute total number of 5 coins. So 5 has given his 4 coins to the last person. So this is going to become 5, and 5 has like one coin again left with him. So he's just going to leave with this one coin. So sorry, not the 4 coins. He is going to distribute 3 coins. So this is going to become 4, and he's going to take 2 coins with him. Right. So this is going to become 4 and 4. So to look at this question is that in a way that how we can look is, so let's say let's first sort all of these coins in increasing order, right? Because at the end what is going to happen is, let's say a monk leaves the town, so he can distribute coins and he can take some coins with him as well, right? He can take some coins with him as well. So initially we check that whether all of these persons have equal amount of coins or not. Right, so we can check them by by a simple trick. So let's say we have total sum with us. So sum. So here sum is equals to 2 plus 2 4 5 6 7. So we have sum as 7. Now we look at the first person, and a total number of person in town are currently 1 2 3 4 5. Right, so total number of persons in town is currently 5. Right. So the first person has 2 coins. So for all of them to have equal amount of coins, they must have 2 coins each. So that means that sum should be total of 10. But here we have only a sum of 7. So what we are going to do is we are going to say that this person has left the town. This person has left the town. That means that now we have 4 persons left in a town, and sum is going to remain same. Why is that? Because we have assumed that this person has distributed these 2 coins into our other persons. Okay, this person has distributed 2 coins into to the other persons, right? So now we have 4 persons left, and the first person is having 2 coins. Right, first person is having 2 coins. So that means that 4 persons left. So we should have a total of 8 number of coins to have equal amount of coins. Right. So because this person has distributed the 2 coins initially, that's why. Right. So this can distribute 2 coins to anywhere or to any of these persons. Right. So now what is going to happen is, so yeah, we have like sum is less. So what we do is we like make the other person leave as well, right? So now we again have a total number of sum as 7, but we have now 3 persons, right? We now have 3 persons. So the first person here we can look that the first person is 1, right? First person has total number of coin as 1, right? So and the sum is 7. The sum is 7. That means that we can equally distribute between all of these persons. So sum is 7. That means that we have 4 extra coins. So with these 4 extra coins, we only try to distribute this 3 coins. Sorry, 3 coins here. Either we can distribute the 3 coins here, or we can distribute none coins, no coins. Right. So this is our choice because we have these 4 coins extras. That's why we can do that. So this is this simple as that, and I have done this only. So we just only have to find out that how many times we have to like remove the persons. So what I did is, let me explain you line by line. So I made a priority queue, and then I'm inserting all of these persons into priority queue, and also I'm taking the value sum, right? So we have total sum, and as well as we have a priority queue. And at the end we have count. So this is the count of persons who are leaving the town, right? So I'm using a while loop while the sum while the sum is less than total persons into p dot top. So p dot top is the coin which coin sorry the first person or the person who is having the maximum top, my maximum coins. So this is going to be p dot top. So we are doing this and we are just checking this. And till this inequality does not hold, or this inequality holds till the sum is not greater than or equals to n into p dot top, we are going to increase our count. We are going to pop one person and we are going to decrease the count of persons. So this is it, and at the end we just print out the count. So this is it for this question, and I hope you have understood it. And if you have any doubt regarding any other question, please feel free to write the doubts in the comments. So thank you.